Hey everyone, thanks for clicking and welcome to this lesson on solving equations involving factorials, which is actually like last chapter in the topic about factorials. So let's get started. I will start probably with the easiest equation, though you will see that it really looks easy, but to solve it like properly with the explanation what's going on there is gonna be a little bit tricky. So our first equation is like 5 times n plus 1 factorial is equal to n plus 2 factorial. And please, if you didn't see the previous videos about factorials, maybe you will find some things not clear. So please, if this happens, go and watch the previous two videos about basics and simplifying the expressions. Okay, now if you have a look at this equation, there are like two ways to solve this equation. I will show you both ways and explain, let's say, the advantage or some tricky points during the solving this equation. So some of you may think about solving this equation like let's subtract n plus 2 factorial from the right side, so we will have on the left side of our equation something like this, which is equal to 0. Now you probably know that this can be simplified or written as n plus 2 times like the second factor n plus 1 factorial is equal to 0, which means both terms in this expression have in common n plus 1 factorial times 5 take away n take away 2, which is a little bit tricky because if you want to write it really properly, it means 5 take away n plus 2. Okay, end of parenthesis is equal to 0. So for those who didn't understand the previous line, here is the explanation how we get from this expression the expression 5 take away n and take away 2 is equal to 0. So we are at the very end of the solving our equation, which is gonna be then 3 take away n is equal to 0. And in this case we are done because now we have like two factors and they are supposed to be equal to 0, which means that the first factor should be equal to 0 or the second factor should be equal to 0. But as we already know, s plus 1 factorial is never gonna be equal to 0 because factorial can never get value 0 for any natural number including 0, as this is from the definition from the factorial. So then the only expression that can be equal to 0 is the expression in the second parenthesis, so 3 take away n must be equal to 0, and this is if and only if n is equal to 3. Okay. There is one more thing you have to think about, and it is expressing the conditions. And from the previous video we already know that we need to find the conditions or the condition based on the lowest number of factorials, so n plus 1 must be greater or equal to 0, which means n must be greater or equal to -1, which is okay for our solution. So really our solution is n being equal to 3. Now Let me show you another way how you can solve this one, and I'll explain very tricky thing also in this operation here. So 5 times n plus 1 factorial is equal to n plus 2 factorial. Some of you might think about taking this approach. N plus 2 factorial can be expressed as n plus 2 times n plus 1 factorial, and now you would probably think about dividing both sides or multiplying by fraction 1 over n plus 1 factorial, but this is a little bit tricky, and you really should know what are you doing and why this operation is allowed, because the fraction is not, or division is not defined if you divide by 0 or if you multiply by the fraction which has 0 in the denominator. But in this case, and from the definition, it is quite clear that any factorial of any number is not equal to 0. Okay, because we already know that 0 factorial is really equal to 1, so there is non-factorial being equal to 0. So we are allowed to use this operation, and this operation would mean that you can cancel these factors. Okay, and now your equation will be 5 is equal n plus 2. So if you take away number 2 from both sides of the equation and you switch the sides of the equation, the solution is again n equals 3, which is okay with our condition. So n being equal 3 is the solution of our very first equation. Now let's go to another exercise or example, which is more or less the same as we did now. So our equation is given like n plus 5 factorial over n plus 3 factorial is equal to 56. Again, we have to define or express the conditions, which in this case we take the smaller number, which is n plus 3 must be greater or equal to 0, so n must be greater or equal to negative 3. Now from the previous video you should already know that n plus 5 factorial can be expressed as n plus 5 times n plus 4 times n plus 3 factorial over n plus 3 factorial is equal to 56. Here you can cancel n plus 3 factorials from numerator and denominator, and you will come to the quadratic equation n squared plus 9n plus 20 is equal to 56. Get away 56 from both sides of the equation, so n squared plus, I'm sorry, here must be 9n, 9 times n, take away 36 is equal to 0. Now let me just remind you, and you can do this quick check, that if you want to factor this expression, you are looking for for two numbers, so that if you multiply these two expressions you will get the expression above. And to find these two numbers, and I didn't write plus or minus because you will find if it's plus or minus when you look for such numbers, and these two numbers have to meet these two conditions. If you add them up, they should sum up to 9, and if you multiply these two numbers, the product should be negative 36. So after a while of thinking and finding divisors of 36, you will find that your numbers you are looking for are 12 and negative 3, because 12 minus 3 is 9, and 12 times negative 3 is equal to negative 36. So you can write this expression as product of these two expressions plus 12 times, and take away 3 must be equal to 0. And again, this is true if and only if n is equal to negative 12 or n is equal to 3. And now you can find the reason for finding the condition. Very useful, because n must be greater than negative 3, which means the only solution of this equation is for n being equal to 3. Okay, so this one was really simple. Let me just give you one more example, which is, in my opinion, quite easy again to be solved, and then I'm gonna show you something which my students probably will find like nothing new happens. Yeah, and you will see. Just stay with me and you will see. So the next equation can be like this: x, or we have the equation like this: x take away 4 factorial plus x minus 2 factorial over x minus 3 factorial is equal to 3. Again, the very first step you should do is provide the conditions when the expression, in this case on the left side, is defined, and it is if and only if x minus 4 is greater or equal to 0. We already know why, so it means x must be greater or equal to number 4. Now, if you think about the expression on the left side of the equation, and we know already from the previous video that we are looking for the, let's say, smallest factorial that occurs in this fraction, and it is of course x take away 4 factorial, so we remain with this as the first term in the numerator, and the second term must be expressed like x minus 2 times x minus 3 times x minus 4 factorial over, and denominator x minus 3 times x minus 4 factorial must be equal to 3. I'm not gonna solve these like in details, but yeah, as a teacher I know I have to do this, so I'm gonna do this. So from these two expressions, from these two terms of the expression in the numerator, you find what these expressions have in common, which is in this case is x take away 4 factorial, which is here and here. So you take this expression and you can write x minus 4 factorial times, and there remains in the brackets parentheses 1 plus, okay, I will do this like this, over x, let me just change these two factors, x minus 4 factorial times x minus 3 is equal to 3, so these two factorials will cancel each other, is equal to 3. Now you simplify the expression in the numerator and it will become x squared, take away 5x plus 7 over x minus 3 is equal to 3. So now you can multiply our equation by x minus 3, which means x squared take away 5x plus 7 is equal to 3x take away 9, which then is like take away 3x plus 9, which means x squared take away 8 times x plus 16 is equal to 0. And I'm pretty sure you can see that this is very well known expression or formula which can be simplified or written like x minus 4 squared is equal to 0, and this is true if and only if x is equal to 4. You have to check this result with the conditions. X must be greater or equal to 4, which is true. So let me just think about it. X minus 4, if x is 4, this is 0 factorial. Let me do just quick check to be sure that the result is correct. 0 factorial plus 4 take away 2 is 2, which is 2 factorial, which is number 2, over 4 minus is 1 factorial. 0 factorial is equal to 1 plus 2 factorial is 2 over 1, which is definitely 3, and this is equal to the value of the right side of the equation. Okay, we are done here. Now let me show you something which maybe you will find, let's say, tricky, but if you think about it, the way we were solving, for example, logarithmic or exponential equations, there were basically a couple of types of them. So my question here, for a while, you should think about the solution or the approach how to solve this kind of equation involving factorials. So basically it means x factorial squared plus 6 equals 7 times x factorial. First of all, the conditions, but this is okay. X must be greater or equal to 0, and it is of course from the set of all natural numbers including 0. So what is your idea behind the equation which looks this way? Now you can pause the video and think about it by your own, and if you would be really, if you are lost, you can come back and have a look. In 3 seconds I'll start explaining. For those of you who thought about substitution, you're right, because in this case we, instead of solving something which looks really tricky, you can use the substitution where x factorial will be, for example, any letter, and let's denote it in this case letter A. So instead of solving this, you will have the quadratic equation which looks like this, and this is something you can solve very easily. So a squared take away 7 times a plus 6 is equal to 0, which means that this is not easy to find or factorize, so we will use the discriminant in this case, which is b squared take away 4ac. Discriminant is equal b squared, which is 49, plus 4 times 1 times okay, let's use the discriminant though. Now I realize that this is something you can factorize very easily, but let's do it. Let's finish it with the discriminant. So 49, sorry, not plus but minus 4 times 1 times 6, which means this is equal to 49 take away 24. So our discriminant is equal to 25, which is good news. Then it means our roots of this equation are negative b plus minus square root of discriminant over 2 times a, which is equal to negative b is negative of negative 7, which is 7, plus minus 5 over 2 times a is 2. So the first solution is 7 plus 5 is equal to 12 over 2 is equal to 6, and 7 minus 5 is 2 over 2 is equal to 1. So now we do the resubstitution, which means that from this one x factorial should be equal to 6, and there is only one number, and this number is 3 factorial, because this is 3 times 2 times 1, which is definitely equal to 6. So from this it means x is equal to 6, to 3, x is equal to 3, and from this possibility x factorial should be equal to 1. Be careful here, because 1 factorial is equal to 1, but as well 0 factorial is equal to 1. So from this part, our next solution, let's denote this one x1, is solution x can be equal to 1, and also x can be equal to 0. Okay. If you want to, you can do the check and find out if this one is really true. Now at the very end, let me just give you one tricky equation to just train yourself. 2 times x factorial, the whole thing squared, plus 3 times x factorial, take away 7, is equal to 0. You can try to find the solution and give me in the comment of the video what is your found solution, and I'll come to your comment and I will tell you if you are true or not. But there is one thing I want to say for my students. These last two equations are really, let's say, advanced equations, but I'm pretty sure you understood what's going on there and how did we solve it. So if you are interested in these two, just study them. If not, then it's okay for me, and also for you and for your future career. Anyway, thanks for watching, and I'm looking forward to see you again, and I wish you good luck. Bye.